Yeah, so hey, I'm Aidan. So I'm just going to preface this talk by saying I haven't been actively working on these gems in over a year, so there are probably questions I won't be able to answer, and if anything's confusing, it's because I'm glossing over details I don't know. But please feel free to ask any questions, stop me anytime. Yeah. So what we're going to cover, so talk about a bit of background. The Magically gem, how that was created, the Mustachio gem, which is built on Magically, and then time and interest permitting, we'll talk about like some performance considerations that we encountered when using this gem, and maybe we'll have time to build the fact, I don't know. So for those who aren't familiar, Jux is a site, is a blogging site. So it's very visual. So this is my personal Jux homepage. Jux is a company that I used to work at a couple of years ago. So it's this very visual presentation of videos and articles, etc. Lots of really full screen templates, different sorts of layouts, etc. So we ran into the problem that we were needing images in a lot of different scenarios, in a lot of different aspect ratios, different sizes, etc. It's a WYSIWYG editor. So, for example, this one photo is displayed 1, 2, 3, 4 times on this, just on this one page, as well as what we give to Facebook for Open Graph tags, what we embed in the HTML for Google to pick up, etc. So there was a need to give images efficiently, and not only to take the original image, but to be able to actually modify it. So you can, on the fly, which I'm not finding for some reason. So you can apply on the fly effects. Okay, don't know why it's not working, but there's things like Lomo effects, tilt shift, grayscale, etc. So the question came up: how are we going to deal with having all these different images? They have to be generated on the fly. We don't know what effects people are going to apply to them. We have to support a lot of different sizes. Those sizes can change. As you saw in the homepage, this layout, all these articles and posts are displayed in different sort of formats. When I refresh the page, it's actually a random layout. So it will actually change for each user that visits and every time I visit. So this means there's a lot of variations to the possible images that we can generate. So how a lot of sites tackle image uploads is, for user-generated images, is that you have an image uploader, you store it on S3 or whatever file storage you want, and then you generate a handful of different sizes that you might need for the different places being presented, like the thumbnail and a small version, medium, large, etc. So let's say we started with this photo. So you not only need to keep the original around, because you want to have the high fidelity version for when you generate the others. You'll need a large version for when you present the full screen. You'll need a small version for when you present it in the gallery. You'll need a thumb version for when you put it in the thumbnail picker, etc. So that's fine. You just generate them all up front and add some sort of extension that sort of keeps track of, okay, what sizes have I generated for this? And so it's all done up front. And this is how a lot of sites do it. It works fine for if you have a relatively small number of ways these images are being presented. because we had a nearly infinite number of variations, and our gallery, the way it was displaying images, we would add new variations all the time. So it could even change. The options could change continually. So as an experiment, I was thinking, and I apologize, it's cut off. But instead of an image tag where you just embed some static photo, what if, as the image is embedded, when you, the browser, is asking to use the image, you tell the server what size you want back, and that's what it gives you. So instead of just calling for the image directly, we're going to call through this API that I called Magically. And Magically supports not only the source image which you pass, but you can pass different parameters. The most common of which being resize. You can say, okay, I want this photo and fit it in a 200 by 200 box. You could also say, okay, I want it to be 200 pixels wide and however tall it scales to. So there's a lot of different variations that we wanted to support. I want it cropped to 200 by 200 square and make it grayscale for certain presentations. So this is really awesome because instead of just having a static photo where you have to decide up front what you're going to support, instead it happens on the fly. It happens at time. The image generation happens at the time that you need them. So the way the architecture works is instead of just talking to static files, you instead talk through, oh, that's better, thank you. So you instead talk through a cache, and you talk through this app called Magically. So what Magically does is takes those parameters, it fetches the source image that we passed in, and then applies whatever transformations we want. So resize in the simple case, it could also be grayscale or what have you. So the other awesome part about this is if we decide to change what's being presented in the gallery, we don't all of a sudden have all these lingering 200 by 500 pixel images that we're not going to use anymore. So there's no state in the sense that you request an image, that's what gets served back. You never have to worry about cleanup on the server end. So this is really nice. You can just let a cache handle the storing of the images. You say, we used a least recently used cache, and so that says, okay, if this, store X number of gigs of files, and whichever one has not been requested recently, throw away those first. So for return visits, it ends up being a fast request because you already have that image generated. And you can put a CDN in front of, this is a cache we had in servers, on our own machines, but we put a CDN in front of it as well, so you get caching in multiple layers. And we just made the decision that, okay, once you've requested this image, it's going to be good forever. So you can set that expiration to be forever. You never have to worry about regenerating those images if your cache can hold all of them. So Magically is this app I wrote, this gem, which can be hosted by itself, and I'll show you that in a second. Or it's actually just a small Sinatra app. Because Sinatra is built on Rack, any Rack app can be embedded with one another. You can actually take a Rails app and embed it within another Rails app. You can take Magically and embed it within a Rails app. So Magically sits on top of a library called Dragonfly. Dragonfly is actually a sort of a full-fledged attachment management gem, so something like Carrier Wave or Paperclip. It handles similar cases to that. I'm actually just using it because it has a nice interface to ImageMagick. So ImageMagick is, think command line Photoshop. It allows you to do transformations on images all through arguments in the command line. And that's what I try and mirror in Magically. So if we just take a quick peek, the documentation,
So there's a bunch of different, there's all setup information, but there's a lot of parameters that correspond very closely to what the image magic arguments would be. So for example, to adjust, that one's broken, don't mind that one. But if you pass flip true, the command line argument actually looks the same in image magic, and we'll see that in a second. But you can not only have these sort of Boolean operations, you can also do things like, I have multiple parameters. So glow takes the amount of glow and the softness of the glow, whatever that means. But these are essentially just being passed through to image magic. So you can think of Magically as an API for image transformation, a web API for image magic. So enough slides. So like I said, Magically is a Sinatra app. So within the folder, you'll find this Magically app class. So it has some configuration, it has some setup, etc. But it otherwise just has routes like you do for a plain old Sinatra app. Because for various reasons, I'll maybe go into them later, we support a bunch of different, it supports a bunch of different syntaxes. So you can either use query parameters, or you can do /q/ and then each sort of key value pair of arguments. So you say, q/ glow / 100, 20 / resize / 200, etc. So there's a bunch of these different, there's a handful of these different syntaxes. So all these routes determine if you're asking for an operation to be done, or if you're trying to look at the home page. So if it sees a source URL, it does the transformation. Otherwise, wrong one, sorry. Down here. So if it sees a source URL, it processes the image. Otherwise, it displays the home page. So this process source is where the actual action is happening. So back in the Magically class, so we take the source URL and we fetch the image from wherever it's coming from. So this can be hosted on S3, it can be from an external site, etc. Magically itself doesn't have any limitation on what that can be. So once that image is fetched, you do the processing, and the options are being passed through as a hash. The options being different transformations that you want to happen, and they're ordered. Luckily, in Ruby 1.9.3, or I'm sorry, 1.9.2 and up, hashes are actually ordered. So the order in which you apply the parameters matters. So for each operation, if you're able to find the processor method, that is, if we support that transformation, if it's a Boolean operation, we just do it. Otherwise, we pass whatever value through. So I won't show how the processor methods get wired up because that's not really interesting. But one thing I really wanted to do with Magically was make it easily configurable and easily extensible. So there's sort of built-in commands that come with ImageMagick, things like resizing and grayscale, etc. But I also wanted to have kind of compound effects, so where you could say, grayscale doesn't mean one particular thing. It has certain thresholds that you set the white balance, or that you set the black level or contrast, whatever. So I wanted to be able to specify these sort of custom effects, and like Lomo, actually comprises a lot of different effects together. So I support what Dragonfly calls shortcuts. So in here, you can actually see, in the back, can you see it all right? Okay. So in here, you actually have the definitions for every single transformation that's supported. So brightness and contrast. I do some checking to make sure that they're actually passing through valid values, that it's a number followed by a plus, a blah, blah, blah. So once it determines that, and these are nasty regexes just to make sure that, the different syntaxes are proper. But if it gets passed in properly, we call the convert command. So convert is the image magic command for doing an operation. So you say convert and then and then the input file, and then some arguments, and then the output file. So here, the process convert is saying, okay, take the input file, which is what we specified with source, apply this argument to it, so the brightness contrast flag with some value, and then the output. Because you can pass multiple parameters in at one time, and I'll show a demonstration of that. So we have the glow with 1.2 and 20. I can also do flip equals true, and I'm able to chain effects really, really easily. So this, in a traditional app, this would have required me writing code, would have required a deploy, would have required maybe some generating of existing images. Here, it is as simple as adding a command line or a query parameter. So, the sort of built-in ones like brightness, contrast, saturation, they call modulate, but these are all, the sort of built-in commands with ImageMagick. I also have more complicated ones like tilt shift, and this, I don't know anything about image transformation or the terms or anything like that. So it was really just me looking at tutorials about how to do certain effects in Photoshop or in Illustrator, mapping in ImageMagick, translating those to the actual, what set of commands, tweaking the parameters or the multiples or whatever to get something that I liked, and then I can add it as a shortcut. So you can pass in tilt shift with some coefficients, and that gets passed to the polynomial function, which is the way the sort of the density in which the blur is applied. So these were really fun to do. I highly encourage, if you find Photoshop difficult and frustrating, you should try doing it on a command line. But it is really, really satisfying to see things, come out the way you want. And trying to think of some example. There were some that I actually, I actually was like looking at the curves in Photoshop. I'd take an original photo, I'd create some layer effect, I think they call it, or mask in Photoshop, and then I'd actually like look at the curve or get it to tell me the polynomial of the curve and translate that to code. So this is all within, like I said, Magically is both a gem and an app itself, so you can actually just clone the repo and throw it up on GitHub, throw it up on Heroku. You can also take the gem, add it to your existing app, and mount it within a certain route. So that's Magically. Any questions about that thus far? Anything you want to see in more detail or anything like that?
Show us the cache a little bit.
Sure. So the cache is nothing special, meaning it's nothing that we built in-house. What we did is because all these, if you have file servers, you have to, you're only going to have that each version of each image stored once, probably. So you have to have a system in front of it that says, okay, where is that image stored, and make sure to serve it from the right place, etc. And as you get multiple servers and do sharding like around the world and whatever, that gets more complicated. Here, because, so we were using, oh my god, what's the JRuby server? Okay, well, we were using JRuby at the time, and not Tomcat, but the other one. I'm sorry? No, it wasn't. I'll think of it. Essentially, it's a server that allows you to have, I don't have a slide for this, but it allows you to basically make these sort of compound apps. So you're able to say, okay, deploy my Rails app and deploy this Sinatra app and deploy whatever, like all on the same server. And also, you know, put Apache in front of, you know, these particular pieces. So what our cache would do is, because this server actually supported you know, sharding in the sense where it would handle the caching on whatever server, you know, happened to generate the image first, and then the servers would then talk to one another. If the one didn't have the image, it would go and fetch it from one that did, if it had already been generated. So the cache was nothing special. It was just Apache cache, I think, you know, whatever the sort of plain old plugin is. And this is really nice because you can throw up as many Magically instances as you want, or as you need. They're all exactly the same. You can, you know, scale them up and down however you want. You know, if you have heavy traffic, you can just throw up more. They're all identical. And because the files are getting stored at the cache level, they're all stateless, and they all you know, just serve one request at a time, and they, you know, that's it. There's no keeping of state. There's no keeping track of have I generated this or not. You know knowing which other servers have it or whatever. It's very simple. So using cache, you know, this idea of using a cache basically as your data store or as your file store is really, really convenient, and something I definitely encourage you to do if you end up building like apps with a decent amount of traffic, or need something where you have to serve these sort of generated files. Do you have any other specific questions? Yeah.
Code that in Magically that deals with this?
Nope. No, and that's sort of the beauty of it. Like Magically, you know, just works as a single node. You can just do requests to it. I didn't put any authentication in there. I didn't put any caching logic in there. Whatever. You could, you know, add rack cache if you want something really simple. You can put, you know, Apache or Nginx or, you know, whatever other like caching server you want in front of it. That's all. You know, nothing is built into Magically. And Magically doesn't have to know what's in front of it. It just says, I get this request, I need to generate it, and I spit it back. And I set caching headers. Yeah.
What are the disadvantages of Magically over our traditional image inversion?
Yeah. So one big disadvantage is because you're only generating them on the fly, your user has to wait longer to see that image the first time. If it's something where they are, you know, clicking an effect and want that applied, it wouldn't be any different, you know, whether it's getting done on the request side or pressing the button causes it to generate and then gets displayed. You know, that's effectively the same.
Could you give us a sense of like how long some of these effects?
Yeah, I mean
like
they.
For like you know,
Yep.
1 megabyte.
Yeah.
JPEG file.
Mhm.
How long
So I can show you. Yeah. So jumping ahead a little bit, but looking at like the Mustachio. Let's see. That's not a good graph. So this is the Mustachio like new route graph. So Mustachio is doing more than just generating it, just applying an effect. It actually has to do phase detection. We'll talk about that later. But you know, generating these, the average response time is, let's see, half a second, 1 second, you know, multiple seconds, and like some of our effects took a long time, like 8 seconds.
Wow.
Yeah, but it's not
the app is doing very little. You're basically CPU bound. Well, you're both CPU and IO bound. So you first have to request the image from an external source. If it's on your own server, that'll be fast. But it's doing an HTTP request for that. Then once it gets that image, it just has the temp file and then runs image magic, convert on it. That's where those two operations are like 98% of the time. All Magically is doing is parsing the parameters and then shelling those both out. So I think either we talked about it or we actually did do a little hack where to get the image, because we did want that image, some images to be generated up front, we would actually sort of seed the cache by just running a bunch of HTTP requests against Magically. So we would, request images, and they'd get generated, they'd get cached, and the requester would throw them on the ground. So this is akin to, running a batch like, generate job like you do if you were generating them up front. So yeah, the downside is that if you are only doing at request time, you have to wait for them to be generated for the first person that sees that image. The image might not be around forever if it gets dropped on your cache, but that's, if your cache is big enough, they'll never get thrown away. That's really no different than if you had a file store that was storing all these. So that sort of scales in the same way in the sense of storage.
How does Google see images?
So it's exactly the same. So I request this, where are we? So I request this image and it's actually just an image. It gives the proper MIME type back and whatever. Yeah, it's exactly the same. Because if it is needing to generate, that image request will be really slow. Google might penalize you for that, I don't know. If it's being generated for the first time. That's definitely a trade-off. Is that you have to know that the first thing to hit to request a particular set of transformations on an image, be it your user, be it some automated thing, will be a slow request. Any other? Yeah.
You said something about ordered hashes and the options.
Yep.
Maybe I'm remembering this wrong, but isn't it in Ruby 2.0 that the fact cannot be ordered hashes?
Not that I know of.
Okay.
And because we were up until like this afternoon supporting Ruby 1.8.7, it actually I think parses it actually passes an array instead of a hash, just as a sort of safety to make sure it's ordered. But if I didn't rip that out already, I will because of the ordered hash. Any other questions? All right, so that's Magically. So if you embed it in your app, you can actually, and there are instructions in the README to do this, but you can actually define your own shortcuts by, basically doing this top bit. So if you're in a Rails app, say, you'd say, Magically Dragonfly configure, and then you can create your own shortcut, a job it's also known as. So, we had specific effects that were sort of custom to Jux, our sort of secret sauce effects. So, some made it into Magically proper, but others, if you have a watermark, say, you can actually define a custom effect for that. So, as a proof of concept, I wanted to show that Magically was extensible. So I don't remember if this was after we actually started using it within Jux or not. Basically, as a way to prove to myself that other apps could be built around it. I don't know where this idea came from, but I thought, wouldn't it be fun if you could, I was really excited about this API for images. So what if there were an API where you can give it an image and it will come back with that same image with a mustache and all the faces? Sensible, right? So I created a gem called Mustachio and a site called mustachify.me. So mustachify.me works, it's just a very thin wrapper around Magically. It just takes a single query param, the source, and will then apply this mustachify effect. So we can throw in any photo we want. Come on. That's a big one. That's going to take a while. All right. So once you pass in this source, it just has an effect that it defaults to, which is mustachify. So it actually does a request out to a face detection API, finds all the faces in the photo, and then takes a mustache image and positions it on all the faces.
Are there different gems you use for that?
So the core piece of it is, it's pretty small. I'll try. So the core piece of it is just Magically. It's just doing the same thing. It's requesting an image, and then it's applying a transformation. To be able to do that transformation, it actually has to do another step where it's actually talking to a face detection API. So this is like a third-party service. We'll see if this works. So it's actually a third-party service that you, like Magically, you send an API, except instead of giving back an image, it gives back coordinates of all the faces in the photo. So I started off with one called face.com, but they got bought by Facebook and shut down. So now I'm using a different one, but I believe this one gives like the eyes, the nose, 2 or 3 points on the mouth, and the chin, or something like that. So I'll show you, but I'm using that data. So Mustachio just has a lot in there, but it depends on Magically. It has its own app where it takes the, and I'll bring this up in a second, but you can actually ask for different mustaches to be applied. Same kind of logic. If there's an image, process the image and show it. Otherwise, show the home page. So, there's a gallery. There we go. So, slow. Okay. So they're actually, this is something I added later, but you can actually pick different mustaches to be applied. So I like number 4. Personally. So the app is only slightly different in that the syntax supports this number as the first argument. But otherwise, it's doing the same thing. It's calling Magically process source, except it does a default operation of mustachify either with the stash number that you pass in, like we just did, or just true. So just give the default one. Or you can also ask it for a random one. So what it's actually doing is, if we look at, like I said, you can add your own, if you embed magically in another app, which is the case here, you configure magically to have new, those are analyzers, that's not the same thing. Okay. So I'll talk about why this is a little different. But basically, this is saying, okay, add a different option for conversion, mustachify. It takes the stash number, and this converts. So Magically is actually using a fork of Magically. By default, Dragonfly, for one reason or another, every operation you call happens independently. So if I call resize and then grayscale, it first does the resize, spits back an image, and then reads that image in, does the grayscale, and then spits out a new image. So you actually lose time in the encoding and decoding of these files. So this was a problem that we ran into, is that this image generation was taking a really long time, and this is one place we found that we could cut it out. So it's a little bit more complicated. So it's actually not in Magically master yet, because just the syntax is a little nastier. I need to figure out how to make it simpler. But basically, it's building up all of the commands, and then it consolidates them all into one single operation. So the encoding and decoding only happen once. So, and those are called factories. So we have a mustachify factory. So it looks at it does a pre-identify. So identify is the image magic command to get the sort of properties of an image. So things like the width, the height, the number of colors, etc. So it gets the size. It converts the image down to 900 max, 900 pixels max on each side, and then sends that. It gets the face data as pixels. So this, I believe, happens here. Face data, there we go. Okay, so it takes in a file. A job is just like a different internal representation of that. And then calls this API to get the face data back, and then it does some normalization.
But how do you identify the face? I mean, it could be an oval or something like a ball.
Yep, so I'm not doing any of that. I'm just talking to an API that says, and I say, tell me where all the faces are, and it just gives me points. It gives me coordinates. So the way that's actually done is pretty complicated. They're pretty.
To a different gem or?
It's actually like a third-party service. It's a website. So I'm talking to a different API. I've experimented with doing it locally, so that you don't have that whole round trip. But performance for this is not really a huge concern for me. And it's just easier. So but basically it looks for contrast where the nose ends and the sides of the face are. It looks for something in a general shape. It looks for the eyes in particular. Knowing that these two dots that look sort of similar. Based on how they're tilted, the nose is going to be straight perpendicular from that. So it has all these heuristics.
Profiles is not identified as a face.
Right. Yeah. So there's it can only and if you've looked at as many.
Your team picture, the guy that was cited.
Yeah. I don't have it anymore, but
Exactly.
okay. But yeah, basically, it has a hard time detecting.
Semi-profile.
Yep. Yeah. So if it's sideways or if there's shadow or et cetera. If it's dog, it doesn't work for everything. But it does pretty well, depending on the service. So it gets this face data back. It then passes it through. Where are we? Factories. It then goes through each face. Grabs the associated mustache image, and then it finds where the center of the mouth is. So I guess this API just gives back the left and right points of the mouth. So it does, it just gets the middle. Then I'm doing some geometry to basically shrink the mustache so that it's a little smaller. Let's see, where are we? So it's some proportion of the distance between the nose and the middle of the mouth, and then rotate it properly, etc. So I mean, this looks gross. It's just geometry. Yeah, atan, square root, etc.
Did you just discover the formula by yourself, or like?
Yeah, I mean, it was like drawing on napkins, like, like oh god, like hypotenuse, like, yeah, I mean, it was really like, okay, if the nose is X, then then the mouth is like half of the distance between these 2 points, and so yeah, I mean that was really what it was. So it's nothing super fancy, but it's doing scaling and it's doing rotation and positioning. So this concatenates some big string of where are we? So yeah, it starts with like a transparent background because you want you're essentially if you've used Photoshop, you create different layers. So you have a layer for each mustache. So you want that layer to have a transparent background. Turn on the alpha channel, which allows transparency. You come up with the coordinates, and then you do a transformation, which is down here. So it's saying distort, SRT, scale rotation transformation it stands for. So you pass in like a couple arguments there, and that positions that that mustache. So it's doing each of these in parentheses. So each mustache is being transformed independently, and they all get flattened at the end. So the layers get compressed. Any questions around that?
Where do you apply the mustache on the face?
So all of this is where it's calculating. So you see like face, nose, and mouth center, etc. This is where it's actually, so here I'm like calculating the height of the mustache, the rotation of the mustache, the mouth intersect, I guess, is the, oh, okay. So where is it? Okay, somewhere in here, I'm actually defining for each mustache, because they all have different shapes. So because they all have different shapes, you don't want to, I started off with this top mustache. So, okay, I figured the bottom should go past the middle of the mouth, and so that was easy to do. The second one, you want it to drop below the mouth. So each mustache actually has a specification that goes along with the image that says, okay, we want the overlap to be this amount. We want the top offset to be a certain amount. So like number 3 or no 4 down there, you want to be a little lower on the face than number 1, or lower relative to the nose. So it was all just like tweaking. It's not anything super fancy. It was just seeing the mustache applied, and it didn't look right. So just playing around with how to get it to look right and look good. So yeah, I didn't bring it up before, but Magic also supports analyzers. So where a shortcut or a job returns an image, you can actually ask questions that give back data. So I want to get the face data back. So you use the same kind of request. So you use the same kind of request, but you actually say, face data equals true. I hope I'm remembering that right. And so then if I did that properly, it will just come back with the JSON. I didn't. Okay. All right. I don't remember what it is, but basically, it has a data support too. So back in Magically, we had so we can get back the color palette. I don't remember. Yeah, analyzer. So it actually gives you back the top X colors in the top 5 most present colors in that image and other things like that. So yeah, I think that is about all I wanted to cover. Other than that, so I made. Again, Magically for Jux to support images within our app, and we were using it and it was working well. I built this Mustachify thing. People at work thought it was funny. I presented at a meetup called Hack and Tell, which if you haven't seen before, I encourage you to check out. But basically, people just stand up and give 5-minute talks on some random thing they built that wasn't that's open source or not work related. So that presentation went really well. It was just a condensed version of this. And later that week, someone in London, I think, no, Ohio, heard about it and made a Chrome extension that takes every image on your page and mustachifies it as you're browsing. So this got a little bit of traction, and my servers were crashing constantly. Then later, GitHub released, this was before I was working there, released Qbot, and one of the handful of built-in commands was Mustachify me. So you could say Mustachify me, O.J. Simpson, and it would fetch an image from Google Images and apply it. This brought down my servers again, and so, yeah, this is the sort of like weird success story of this little app that is a complete joke. That's by far the most successful thing I've ever made. It's getting. Let's see. So in the past 24 hours, it's getting an average of 102 requests a minute. That API I'm using, I registered for a free account, and I'm over my limit by 19 million, 19 million requests, but they haven't implemented capping yet. Yeah, that's the blue is how much I ever made. So that's Magically and Mustachify, the little apps that no one knew you needed. Thank you. Really quick, a couple shameless plugs. Jesse Chan Norris asked me to tell you that GoRuko, the Gotham Ruby conference, call for proposals is open for another few weeks. So you should definitely do that. They are open to non-Ruby topics also, and not necessarily experts. You don't have to be an expert. Also, if you're a newbie, I run a meetup called Hacker Hours that is like a community of people learning to code. And we meet twice a week. So if you want to learn more Ruby, if you want to get feedback on your code or whatever, I encourage you to check it out. Thanks for listening.
Thank you.